undergraduate mathematics lessons. We're going to focus on the power rule. This will be part 1, part 2 will follow. So here, we're going to look at how one could apply this rule, the integral of u to the n du. The result will be u, we just add 1 to the exponent, then divide by the new exponent, and of course, this will only work when n is not equal to -1. Of course, in other books, they express it in this fashion, wherein we have f at x to the n, and outside we have the derivative of f at x. So we just add 1 to the exponent and divide by the new exponent, and again, n should not be equal to -1. So let's look at this example. Right, first of all, we will have to write this one in exponential form. So we have this cubed root of n. First thing we need to recall that the nth root means a to the 1 over n. So this one will just be x to the power 1 over 3. And this one here will take it up. When you take it up, the exponent will not be -1, so we won't have any problem. The exponent is not -1, the exponent is not -1, so all we have to do is to add 1 to the exponent and divide by the new exponent in both cases. Right, so we have to recall that when we add 1 to 1 over 3, we're going to have 4 over 3. It's like we're adding 3 over 3, and that will give us 4 over 3. Then we have to divide by 4 over 3. So this division can be written in, we can express it in this form. And then when we change this division sign into multiplication, the numerator becomes the denominator and the denominator becomes the numerator. So we're going to have it in that form. Right, so once again, we know that this can be expressed in that form. So we're going to add 1 to the exponent and divide by the new exponent, and we're going to have that. And for the second one, we do likewise. We add 1 to -1, we get -2, then we divide by -2. Then we can simplify this one here. That one over there, we know that we said the nth root will be given by this, so we won't have any problem. One would then say, right, if I have a to the power a, m over n, I may as well write it as a to the power m all to the power 1 over n, and 1 over n means the nth root, as we indicated earlier on here. Right, so that one here, we will write it as 3 over 4, the cubed root of x to the power 4, and this one we take this down, and positive times negative will give us negative. Remember, when we take this one down, the sign of the exponent will change to positive. And we're done. This completes the problem. Right, we're going to move on to the next example. More problems will follow in part 2 as well, and we're going to have more videos of this kind. I hope that they will be useful. Right, let's have a look at this one. In a situation like this, we then say, right, let's make use of that rule that says if we have a plus b over c, then it's a over c plus b over c, this rule. All right, so we apply this rule of this one. We know that x squared over x squared will just give us 1. So x squared over x squared will give us 1. So this one here, when we take it up again, we know that the sign of the exponent will change. And fortunately, we are not going to have -1. Have it like this. When we integrate a constant with respect to x, we'll always get that constant times x. And this one here, we're going to add 1 to the exponent and divide by the new exponent. Right, so that rule says if we have a constant and we want to integrate with respect to x, then we just get that constant times x. And of course, after we have integrated completely, we need to put in a constant. Right, we go back to our problem now. Say, right, the integral of 1 with respect to x will just give us 1. Will just give us x. Then this one here, we will just add 1 to the exponent, then divide by the new exponent. That is, we're going to make use of the power rule on the second one. Right, and this is what we're going to have. This, we can express it in this fashion. We know that plus divided by negative will give us minus. And if we want to make the exponent positive, we'll have to take this expression down. That is, the integral of this will be given by that. Took the exponent, we took this one down, then the exponent becomes positive, and we know that x to the power 1 is the same as x. And of course, this positive divided by negative will give us negative, and we're done. Right, that is that concerning this problem. Then we move now to this one. In a situation like this one, we're going to say, all right, let's take this whole expression up. Then the sign of the exponent will change, as we illustrated in the previous slides. So we're going to have this. Then from there, we take what is inside the bracket here. We differentiate it with respect to x. We get 1, so we know that there is 1 here. So we have 1 dx there, and that will serve as our du. Later on, of course, we're going to handle the same problem, making use of the u substitution. So in a situation like this, wherein when we differentiate this expression inside the bracket, we get what is outside the bracket. We then add 1 to the exponent, then divide by the new exponent, as long as the exponent is not minus 1. So this is what we're going to do. We add 1 to minus 1. We add 1 to minus 2, we get minus 1, then we divide by minus 1. Then once again, we're going to take this down, then the whole thing will just be negative. Minus 1 over x plus 1 all to the power 1, and we know that to the power 1 will be the same as just x plus 1. That's it. So we're going to take the same problem, then you do your substitution. It's up to you. You can make use of whatever method that you are comfortable with. Right, so first thing we say, right, let's take this expression inside the bracket, let's make it u. Then when we differentiate du with respect to x, we're going to have 1 here. Then we take 1 dx over, so we're going to have du equal to dx. Right, so we go back to our problem. So right, this can be expressed in this form. In the place of x plus 1, we put u. In the place of dx, we put du, and this is what we're going to have. The next, of course, we take this one up, power minus 2, making use of that rule again. Right, then this one, the exponent is not minus 1, so we'll have to add 1 to the exponent, then divide by the new exponent. And of course, to recall that after we have integrated completely, we need to put in a constant. Right, so this expression, or the original problem, is in terms of x, not u, so we'll have to substitute back later on, but let's first of all take this one down to make the exponent positive, and the whole thing will be negative because we're having plus divided by negative. We take this one down, we're going to have 1 over u to the power 1, which is just u plus c. Then we recall that u is the same as x plus 1. So in the place of u, we then put in x plus 1, and we're done. Right, we're going to continue like this, and the next video on PowerPoint, on this power rule, will follow. That will be part 2. Let's see what's going to happen if we have it like this. So once again, we differentiate expression inside the bracket, we get 2x. Oh, that rule will be, we will be able to make use of that rule. So we know that multiplication is commutative. 2 times 1 is the same as 1 times 2. So we can express it in this form. So this will be our du, then that will be our u. So all we have to do is just to add 1 to the exponent and divide by the u exponent. So we're going to have to the power 5 divided by 5 plus a constant at the end. And we're done. So we take the very same problem. Now we're going to make use of u substitution. We take the expression inside the bracket, we make it u. Then when we differentiate, this is going to give us 2x. So we take dx over, then we have 2x dx. So when we do our substitution, in the place of this x squared plus 3, we're going to put u. In the place of 2x dx, we're going to put du. Then as it stands right now, that is in the same way as we have our power rule. The exponent is not minus 1, so we'll just add 1 to the exponent and divide by the new exponent. We have replaced this x squared plus 3 by u, because you're saying here it is u, so we have u to the power 4 du. This dx dt, we said is du there, so we just replace it by du. Right, so we add 1 to the exponent, then divide by the new exponent, and this is what we get. The original problem is in terms of x, not u, so we substitute back. We recall that u is the same as x squared plus 3. So in the place of u here, we're going to put x squared plus 3. And as you can see, the result that we have here is precisely the same as that one. Both methods are applicable. Of course, we have quite a number of methods that we can use, but let's stick to this one. We can also multiply this 4 times by itself, then multiply the result by 2x, then apply the power rule, but that I think will be cumbersome. Let's see what's going to happen if the 2 is not there. We had 2x, right now we just have x. In a situation like this, we then say, right, let us multiply by 2, then multiply outside by 1 over 2. 2 is a constant, we can multiply by 2, then multiply outside by 1 over 2. This 2 and that 2 will cancel, we'll be able to go back to that. Right, then after we have done this, we then do exactly what we did in the previous slide. We say, right, when we differentiate this, we get that, so we'll just add 1 to the exponent, then divide by the new exponent, and finally one can then say, we have this 1 times that, then 2 times 5 will give us 10. You can write it in this form, and we're done. And this completes the problem. Right, so let's see what's going to happen if instead of x, we have 5x. In a situation like this one, we recall that because 5 is a constant and we don't need it. Remember, when we differentiate this expression inside the bracket, we're going to have 2x, not 5x. We will then take 5 outside the integral sign. Side 5 is a constant. We can take it outside the integral sign. And then we need that 2 here, because when we differentiate this expression inside the bracket, we get 2x. We know how to introduce the constant. We multiply by 2, then divide by half. Or sorry, rather multiply by half. So we're going to have 5 over 2 there, then we're going to have 2x over there. Right, so it is the way we want it. When we differentiate this, we get that. So we'll just add 1 to the exponent, then divide by the new exponent. Then at the end, one will see that 5 and 5, we can cancel it out, and with just 2. So we're going to have half. And we're done. This completes the problem. Right. Let's have a look at this one. We already know the techniques now, so there won't be any problem. First of all, we know that square root means to the power half. Then when we differentiate this expression inside the bracket here, we get 3x squared. We don't get 5x squared, we get 3x squared, so we don't need 5, so we will take it outside the integral sign. Then when we differentiate this, we get 3x squared. We're only having x squared, so we know how to introduce a constant. We'll multiply by 3, then divide the outside by 3. So we're going to have it like this. Then next, of course, we say, right, since when we differentiate this, we get what we have outside the integral sign, then all we have to do is to add 1 to the exponent, then divide by the new exponent. When we add 1 to the exponent, we're going to have half plus 1, and that will give us 3 over 2. And we know that dividing by 3 over 2 is the same as multiplying by 2 over 3. So we can express it in this form. Right after we've done this, then we say, right, this 1 times that will give us 10, and the 3 will give us 9. So this will be our final result. Right, so we move now to the last problem. we want to apply the same technique on this one and this second term. Right, to take this up, the exponent will be -2. It won't be -1. We're going to take this one up, then the exponent will be -half. Then once again, we say, right, we're going to need 2x here outside. We're just having x. So we put in 2, then we multiply by 1/2. In the same way, when we differentiate this, we get 2x, we don't get just that. So we take 3 out, then we introduce a 2 and multiply this by 1/2. Right, then next, of course, we integrate that one. When we differentiate expression inside the bracket, we get this. Remember, we can take this half outside the integral sign, and of course, we can look at it in this fashion. We know that the integral of the difference is the difference of the integral, so we will have our integral sign again here. Then this one will be outside the integral sign. Then we're going to say, right, because when I differentiate this, we get that. Let's just add 1 to the exponent, then divide by the new exponent. In the same way, when we differentiate this one, we get that. So we will need to add 1 to the exponent and divide by the new exponent. But we know that -half plus 1 will just give us +half. And dividing by +half is the same as multiplying by 2/1. Right, then we write it in simplified form. Then we say, right, let's take this one down to make the exponent positive. The whole thing will be negative because we're having -1 here. And here, 2 and 2 will cancel, then we're going to have 3, the square root of that. So we have it in this form. And this completes it for today. So we get this as our result. We can express it like this. And that brings us to the end. Thank you so much for watching this video. And remember to subscribe and to like the video. Thank you.